So it's given that AB is parallel to CD, right? That's these two lines. Now, we already learned about parallel lines. When parallel lines are cut by a transversal, it tells us something about some of the angles. Yeah. You're saying the line segment, AE? That might be true, but that's not what we could make a conclusion based because the lines are parallel. Like, because the lines are parallel, there's something else that we know about angles.
Just a guess, but I want to say right if they turn into right angles.
Parallel lines, no, not necessarily. What's that? No, I mean, we do have vertical angles here, but that's not related to the parallel lines. Yeah. Wait, let me see. You're saying angle ABD, right? It's congruent to what? BDC? It's kind of like that, except that these angles are interior.
Sorry, yeah, it's congruent interior angles or something like that.
Alternate interior angles. Congruent alternate interior angles. Right. That's it. Yeah, somebody said it the armpit of the Z. Right? Remember when I was doing the armpit of the Z thing, which you never write on anything, by the way. That's just between us. Right? The armpits of the Z are congruent. Same thing the other way, too. So I know that this angle here is also congruent to that angle there. Right? Does that make sense? Right, because I'm just looking at the Z backwards. So when they tell you parallel lines, look for transversals that go through them and mark the angles that are congruent, the alternate interior angles. All right, so let's write that. AB is parallel to CD because it's given. I'm not going to chunk all of the givens this time because I want to say because of this, I know that angle A is congruent to angle B, and at the same time, angle A is congruent to angle C, And at the same time, angle B is congruent to angle D. A transversal is simply a line that goes through other lines. Right? So like DB is going to be a transversal in this case. That's what gave us those angles. And AC will be the other transversal. Right? So those two angles are congruent. Now, every time you write something, you have to give a reason for it, right? Now, and you know how I like to say if then. We want to write it like this. If something, then something. So I'll say it this time. If two lines are parallel, I'm sorry, let me rephrase that. If parallel lines are cut by a transversal, then alternate interior angles are congruent. Yes? No. Because remember, bisect means to cut in half. And we don't know. Well, actually, I could tell you right now, just visually looking at it, this line is not bisecting that line. Maybe it's bisecting this line, maybe. I don't know, but that has nothing to do with why these angles are congruent. Now for the next given. BD bisects AC. BD bisects. You know, I like when she said it. She said it correctly. Line segment BD bisects line segment AC. I almost never say line segment because we know what we're talking about, but the proper way to say it would be like that. So let's see. If BD is bisecting AC, which is given to us, that means this line is cutting this line in half. So what's the conclusion from that? Go ahead. Let me just make sure. BD is doing the cutting. AC is the line getting cut in half. So if this is the line getting cut in half, yes. Those are the two congruent pieces. And the reason for that would be, well, let's write down the statement first. AE is congruent to EC. Why? That is a definition of bisects. All right, the word bisect means to cut in half. So that's a definition of bisect. All right, so I have an angle here. I have another angle here, and I have a side here. Now, even though it's like AAS on here, I always have to look at the picture and make sure. Is it AAS? Right, yeah. This angle is congruent to this one. This angle is congruent to that one. This side is congruent to that one. But look at just one triangle, AAS. S is not in between the two A's. Therefore, it is not ASA, it is AAS. And that's it. Number 5, triangle ABE is congruent to triangle CDE by angle side congruence. Does this make sense? So the key concept here, every time you see parallel lines, what should you look out for? If it's cut by transversal, you'll be looking out for those congruent alternate interior angles. The armpit of the Z. Cool? All right. That's it. I'll put up one more. Remember, look for the parallel lines cut by the transversal, and you know that the armpits of the Z are the congruent angles. The reflexive property is also something that you'll use on this, right? This side is congruent. This side for this triangle is congruent to this side for that triangle. Whoa, HL? If you're going to say HL, there are no right angles, so we don't have a right triangle. Hold on. Okay. If it was a square, it would have right angles. And we don't have any right angles here. At least it doesn't say so. What's the thing that we could put in based on the lines being parallel? Yeah. Angle BCA is congruent to angle CAD. Yep. Does that make sense? Do you guys see the Z? The armpits of the Z are congruent. That's only when you have parallel lines cut by a transversal.
Can you also say CAD?
Good question. I'm going to mark that in green. And you can't, so don't write it down. But it's a very good question. You're asking if this one could be congruent to this one, right? Are these lines parallel? No. We don't know. They might be, but we don't know. We could probably conclude that, but you need to have a big proof to even show that these lines are parallel cut by a transversal. We don't know the lines are parallel, in other words. All right, so only when parallel lines are cut by a transversal. And that's it. Like we have an angle here, congruent to an angle there. This side is congruent to that side. This angle is congruent to that angle. Right? Kind of like just block off one of the triangles for a second. Which way is this? Yeah. AAS. The side is not in between the two angles. If the S was here, then it would be ASA. All right, and just write it out. Angle B is congruent to angle D because it's given. And that's an angle, so I'm writing angle right here. That's a given. I'm going to chunk the other given there too. AD, so comma, AD parallel to line segment BC because it's given. Because the lines are parallel, I know that angle BCA is congruent to angle DAC. Why? Because if parallel lines are cut by transversal, then alternate interior angles are congruent. So let's see, I just showed another set of angles. Every time you write congruent, figure out what type of congruence it is. And then the last thing is the reflexive property. AC is congruent to AC. That's because of the reflexive property. And finally, that's it. We have angle side. Triangle ABC is congruent to triangle CDA because of angle side congruence.